Welcome to the cold and snowy white Belgium fields. Cold today, -1, but we have a job to do. Behind me I have still the battery box I assembled in last video, and today I will configure the V19. A lot of work to do, let's dive right into the video. Two years ago, I made a pretty popular video about the JK-BMS settings. Back in the day, it was still the V11, still available today and bulletproof. 2 years ago, JK started releasing new models, V14, 15 and 19. More options, another form factor and a breakout board for external connections. V14 and 15 are still available today, but support ended somewhere in Q2 2025. Now, how to distinguish model V19 from 14 and 15? Well, V19 has no pre-mounted cable for the most positive voltage. There's no connector for the heat pad, just a single screw, and there's the UART connector to connect the display. The BMS comes in many flavors, several max amps. You have the 150 amp model, 200, 300. You have 1 amp balancing, 2 amp balancing. So check with your reseller to select the best option for you. You can configure the BMS via 2 options, via RS-485 and a personal computer. I will show this later in the video, but now I'll start with the mobile phone. If you don't have the application, you can download it from the Play Store. It's also available for Apple. And good news, it's the same app for the V11 up to V19. Activate Bluetooth and start the application. Compared to old style V11, V19 comes with a lot more infotainment and settings. When you fire with the BMS, first step you have to do is set technology, number of cells and the capacity of each cell. To change these settings and to enter the advanced settings menu, you have to enter the standard password 123456. A very important note, if you change the technology, all advanced parameters will be changed to the standard parameters of that technology. That means you have to re-enter all parameters, so be aware of that. The first screen is an overview, a real infotainment. It gives a global overview, but you can't change any settings here. On top we see the Bluetooth icon, means we're connected via Bluetooth. The time shows the time the BMS was active. Charge, discharge, balance gives the status of that option. You can switch this off, but then you have to go to the control menu. Standard charge and discharge are on. Balance becomes active when certain conditions are met. Later more on that. Voltage and current speak for themselves. When current flows into the battery, the value becomes negative. Let's go over all the other parameters. Battery power shows the actual battery that flows in or out the battery. The battery capacity is the total capacity of the battery. It's the value you entered previously. Remain capacity is capacity available in the battery. The battery needs to make at least 1 full cycle to have a correct value. Remain battery is a calculated percentage of the remaining capacity, also known as SOC or state of charge. Like above, a full cycle is needed to determine the correct state of charge. Cycle count is energy measured by the energy or coulomb meter. For every 300 amp hour of energy in or out the battery, the counter is increased by 1. The cycle capacity is the cumulative sum of energy that went in and out the battery. Over the years, this number will grow to 5 or 6 digits. Battery T4 is one of the 4 temperature sensors. Heating current is current for the heat pad, if it's connected. The maximum current is 3 amp. If connected to a 55 volt battery pack, we're over 150 watts. Time emerge is the time the emergency setting remains active. I think it's standard 1800 seconds, so 30 minutes. And this is a setting when your BMS is blocked because cell low voltage, high temperature or any other error, you can just overrule that by activating the emergency switch. You should try to avoid the usage as much as possible, but this of course can help in an emergency. Time enter sleep. If there's no usage of your battery pack, no input, no output, after the number of defined seconds, your BMS will go into a deep sleep and using microamps instead of milliamps. Standard setting is 86,400, that corresponds with 24 hours. It's less useful for my or maybe your Powerwall, but for smaller setups with 100 amp batteries and 12 volt setup, this might be a useful setting. Average cell voltage speaks for itself. Cell voltage difference is the voltage difference between the lowest and the highest cell. When in the flat zone, it should never be more than 20 millivolt or 0.02 volt. Typically it's 0.002345 volt, so it's very small number. The balance current is current flowing from the highest to the lowest cell when balancing is active. MOSTemp is the real-time temperature of the MOSFETs inside the BMS. The T, X are temperature sensors to monitor the temperature inside the battery box. Heating status is the status of the heating port. You have to activate this as well in the control menu. Detailed log count is the number of lines inside the log of the BMS. You can access this by clicking on the three dots in the right upper corner. PCL module is a module inside the BMS that's limiting the current between stacked boxes. If you add a new battery with a low state of charge and the first battery has a high state of charge, then high current can flow between battery boxes. Parallel current limiter, or PCL, will help to avoid this by limiting the current. This needs to be activated in the control menu as well. I have 4 more parameters to discuss at the bottom of the screen. We have the cell type, that's the chemistry we're using, it's LFP. This BMS supports lithium-ion, LFP and LTO, and here you can verify you chose the right chemistry. The display has a little buzzer. You can activate this, for example, for a low state of charge, high voltage, high temperature alarm. You can set the buzzer, but I will come back to this later. I will show you how you can do this. It's a bit the same for the dry 1 and dry 2 alarm. There is a small relay inside the BMS and you can set this for the same parameters. There are, I think, a dozen of parameters like state of charge, low voltage, high voltage, temperature, where you can trigger a relay. You can access these dry contacts on the front of the panel. It's the green breakout board you see, and there you can make a contact with a wire and activate a light or an external alarm. But more on that later in the YouTube clip. Cell voltages show voltages of all cells in your pack. The cell value in blue is the cell with the highest voltage, in red the cell with the lowest voltage. Next is internal resistance. Don't give too much attention to this, but if one value is totally different from others, it's most probably linked to a nut that isn't at the right tension or a broken balance wire. Now let's swipe to the next step and enter the advanced settings menu. You probably have to re-enter the passwords 123456, and now you will be able to make changes. Start balance voltage is set at 3.4 volt. When one cell hits 3.4 volt and deviation is more than 10 millivolts, I will start balancing. Of course, you have to activate the balance in the control menu. Maximum balance current for this model is 2 amp, so I use the full 2 amp. Cell OVP, or cell over voltage protection, I set mine at 3.55 volt. Standard value is 3.65 for LFP, but there's only 0.5% capacity between 3.55 and 3.65. And this way I put less stress on the cells. Volt cell RCV, or requested charge voltage, is the bulk voltage And this voltage is reported to my Victron ecosystem, and the system will not charge above 3.45 volts. SOC 100%. I'll set 3.445 volts. When the system or one cell hits that voltage, 3.445, the system will report a state of charge of 100% and set the remain battery value to 100% in the main menu. Cell over voltage protection return. When the voltage drops below 3.44 volt, the battery will accept a charge. This 3.44 volt might look a low voltage, but even with a relatively small load, voltage will quickly drop below this voltage. Cell under voltage protection recovery. I have set mine to 2.8 volt. Some use a lower voltage, but if you have a high load at 2.6 volt, the voltage will drop again very quickly and battery pack will be disconnected again from the inverter. SOC or state of charge 0%. It's a voltage where your counter will be reset to 0%. I have set my voltage to 2.65 volt. Cell under voltage protection. When this voltage is reached for one cell, BMS will disconnect the battery and only reconnect when the under voltage protection recovery is reached, which I set previously at 2.9 volt. Power off. It's the voltage where the BMS will shut down. I have set mine to 2.52 volt. It's recommended 2.5 or above. So you need a manual restart to connect the BMS again with the battery pack. This is really the minimum voltage. If you go lower than 2.5 volt, you will damage your battery cells. So you really have to avoid this. Volt cell RFV stands for requested float voltage. I've set mine to 3.375 volt. To use this setting, you have to activate the function in the control menu. This is also a voltage that is reported to your Victron system if you, of course, use the Victron ecosystem. Smart sleep. I have set mine to 3.19 volts. When cell voltage is at this or below voltage and there is no activity, the BMS will go into sleep mode when the time smart sleep timer is set in the control menu. Usage is maybe limited for our daily overhead power setup, but it's intended for smaller 12 volt emergency setups, where you can put the battery in sleep mode when there is no power coming in or going out. When in sleep mode, the battery uses microamps instead of milliamps, and you have to add a charge or use the battery to wake up the battery again. Continued charge current max, the maximum current you can charge your battery pack. This is a 200 amp BMS. I prefer to throttle it a little back, save some 20% headroom and charge at a maximum rate of 150 amps, which is already a massive 7 kilowatts, so not that bad. Charge OCP delay. You can charge temporarily at a higher current for a number of seconds. It depends on your setting. I keep the standard 3 seconds. Charge OCPR or charge over current protection recovery. When you overcharge longer than 3 seconds, the BMS will go into protection and disconnects the battery for 60 seconds. Now we have the same settings for discharge, continued discharge current, discharge over current protection delay, and discharge over current protection return. I didn't change the standard values, just added a 20% safety margin and limited the discharge current to 150 amps. Charge and discharge over temperature protection and charge over temperature recovery are set to 50 and 45 degrees. These values are available in the datasheet. These temperatures are reported from the 4 temperature sensors, not the BMS module itself. If one sensor is triggered, then the BMS will disconnect the battery. Now we come to the very important setting, the charge under temperature protection. I've set mine at 1 degree. Standard it comes at -10 or -20. it was absolutely wrong, so make sure to change this setting to a positive value. You can't charge LFP chemistry at a negative temperature. So very important to change this to a positive value. And of course, it has to be lower than the under temperature protection recovery. It's only very small histories, but it just works fine for me and my setup. TMP heating pad, this is the setting if you have a heating pad connected to your BMS. I don't use it, I don't plan to use it in the future. It's very rare that it freezes or gets below -1 in the shed. But if you want to use the heating pad function, you have to activate this in the control menu, and here you have to set your boundaries when you want to activate and deactivate the heat pad. The MOS or MOSFET over temperature protection and return values are for the protection of the MOSFETs inside the BMS module. Protection starts at 90 degrees, and I'll put the module back to work when it's cooled down to 80 degrees. SCP delay in microseconds, or the short circuit protection delay. This parameter was used in the past for connecting new inverters of high inductive load that looked like a short. The BMS accepts a short for 5 microseconds before disconnecting the pack. If the BMS detects a short, it will disconnect the BMS. Device address is the address you set via the dip switches on the front panel. The OK button is grayed out. You can only set via that same front panel. First and only battery, so I should the value set to 0. This is important if we want to access the battery via RS-485 and computer. I will demonstrate this in a few minutes. Data stored period, 3600 seconds. Every hour it saves the values of the most important parameters. You can later access this data or import it into Home Assistant to generate nice graphs. RCV time, requested charge voltage time measured in hours. It's the time the BMS keeps the charge at the RCV voltage. I have set mine to 3.45 volt. It's called the absorption phase. This will allow the balancer to do its work. No need to charge higher. I mentioned this before, there is almost no capacity left between 3.45 volts and 3.65 volts. When the RCV timer parameter is triggered, you enter the RFV time, the requested float voltage time. BMS will keep this float voltage for the next 8 hours. It's a parameter you have to set. The RCV and RFV are used when there's communication between BMS and your charger inverter via CAN or RS-485. For the moment I don't use this setting. I prefer to keep the cells for a longer time at 3.45 volts. In case of cell unbalance, it gives the balancer some extra time to balance the difference out. Emergency time is the time the emergency setting remains active. I demonstrated this earlier in the video. You can overrule safety settings, but it's not recommended and should be avoided. After this time, battery will be disconnected again. User private data. It's a free-to-use field for battery manufacturers. You can enter whatever you want. Some vendors use it to store the manufacturer dates or serial number for the battery. UART stands for Universal Asynchronous Receiver Transmitter. That's a mouthful. The UART port 1 is the most left port on the breakout board. It has the standard value of 001 JK-BMS. This will allow you to connect the BMS via PC with the JK-BMS software. I will come back to that in a few minutes. UART2 is to interconnect the JK-BMS. If you stack battery boxes, you have to use a UART2. Both RS-485 connectors at the right. Just daisy chain the boxes by using a regular UTP cable. UART3 is the physical connection to the LCD touchscreen. CAN protocol is protocol to communicate with your inverter. It's the second connector from left. Click and select your hardware. The new BMS has a buzzer. You can select for which parameter you want to activate the buzzer. If selected, you have to enter the trigger value and the trigger release value. Same for the two relays. Inside the BMS there are two relays. You can switch on a light, a buzzer, a fan when a setting is triggered. Select the parameter and set the value where the relay has to close and open. For the wire resistance, you can add extra resistance. Here all wire lengths are the same. I recommend not to change this. I think I tackled most of the items in the control menu during the video. Left, a screenshot of the latest generation. Right, a 3-year-old BMS. What a difference. This proves JK invests a lot in engineering and development. This was the mobile phone procedure. You can have a similar view and perform firmware upgrades, make reports and so on via RS-485 and computer. Let's start with installing the software. The link is available under the video. We're back in the shed and let's connect our battery with RS-484 and personal computer. We already installed the software, now we have to connect the battery with the computer. Now we have to decide in which port we have to connect the UTP cable. We have 5 ports. At the right we have the RS-485-2. This port is used to interconnect multiple batteries. If you want to stack them, if you want to daisy chain these batteries, you have to use these ports and use a regular UTP cable to connect battery 1 with battery 2 with battery 3. At the left we have another RS-485 and a CAN port. This is to connect your inverter or other hardware from your Victron ecosystem. Important, if you use the computer, you have to use this port, the most left port. Set all your dip switches to 0. Not really needed, but I have only one system, so I set it to 0 and connect it. Like this. To connect our battery box to a personal computer, we need a cable and an interface. It's the USB to RS-485 interface. Andy from Off-Grid Garage tested a dozen of these interfaces and in conclusion, they all work. This is the cheapest model, costs only a few dollars. This is maybe $5–6. The difference between this one, it came with an extension cable and it's also electrically isolated. So it has some optocouplers inside the device. Now, how to build this cable? I just took a regular standard UTP cable. Just remove the shielded jacket from the cable. Pull back the unneeded wires. Just keep the orange, white and the orange. See, for the both connector, I kept orange, white and orange. The full orange goes to A and the orange, white goes to B. Same for the other one. Maybe not that visible. Here A is the full orange, B orange, white. Let me connect the unit. Let's see which COM port is addressed to our interface. We have the ports and LPT, and I received a COM3. We're lucky, we're already at COM3. Press connect. We already have all our data, the same data that's available on our infotainment screen, the first screen of the app on the mobile phone. You can go to settings. Here you can see all the settings. If you want to change something, we have to enter our password. And you can change it, click on send, and you change the parameter. We have the control tab. If you want to change something, smart sleep, the heating pad, you can activate everything just like you can with the application on the smartphone. Our log file, the hardware, software, serial number, everything is available here. The advantage, if you have a PC running at your system, you can install VNC or any other remote software and take control from anywhere in the world. Let's end the video here. If you have questions, remarks, if you want me to create a cheat sheet with all parameters and settings, just let me know in the comments. I'm really there to help you. Thanks for watching. This was Frankie for EasyPowerwall.com.